unveiled its vision for an electric truck in November 2019, it shocked the world.
Like 100 years, trucks have been basically the same. We want to try something different. So I present to you the Cybertruck.
Elon Musk has been hyping the Cybertruck as Tesla's best product ever. And 4 years later, the first deliveries have begun.
It's very rare that a product comes along that is seemingly impossible, that people said was impossible, that experts said was impossible. And this is one of those times.
But getting the truck to market has been challenging. Musk has repeatedly emphasized how difficult building it has been.
The Cybertruck, I've driven the car, it's an amazing product. I do want to emphasize that there will be enormous challenges in reaching volume production and then in making the Cybertruck cash flow positive. We dug our own grave with Cybertruck.
You're building a stainless steel vehicle, which has really been done hardly ever in the history of the auto industry, and that alone was going to make it challenging.
Stainless steel is tough to tool for, it's tough to work with, and this is, in some ways, a really giant experiment, which I think the whole industry is watching with some interest.
I think they've signed up for another production hell.
So we're able to make the skin out of thick, this ultra-hard stainless steel. It's really hard. We're going to show you just how hard. It's ultra-hard, cold-rolled stainless steel alloy that we've developed. We're going to be using the same alloy in the Starship rocket and in the Cybertruck.
We really wanted to use stainless steel.
Franz von Holzhausen, Tesla's chief designer, said the design of Cybertruck was the direct result of using stainless steel.
You could only break form and form it in one direction. You can't do compound curves with the thickness of the stainless steel that we're using. So it really led us to a design that was really planar, really simplistic, and was also a chance to break the paradigm of what pickup trucks have been for the past 60 or 70 years.
The look of the vehicle has been the topic of controversy. Frank Stevenson, who has designed vehicles like the BMW X5 and the updated 2000 Mini Cooper, is skeptical of its simplistic, aggressive design.
So it's very, almost an origami style of design. It's angular, it's hard, it's aggressive. It doesn't feel natural when you look at it. So I can only figure it's a view from Mr. Musk that he's looking at a future that isn't a very happy future, more of a bleak look to the future.
When the Cybertruck was unveiled, it was slated to be delivered in 2021 and be reasonably priced.
There'll be 3 versions, but it's gonna... That's the price without any incentives. That's just like the price without any incentives.
Several delays later, it is finally here, with different specs and pricing.
We saw them roll out several and hand them off to, be made, produce, and sell this quarter. Nobody really knows.
In the 4 years since its debut, the Cybertruck has had a long and arduous road to production. Internal documents revealed how delayed the development of the truck was in 2022.
Tesla had planned to have this vehicle start production in 2021. That didn't happen. They have talked about the pandemic and wars that disrupted supply chain and more. That's legitimate, but they were also still working out kinks with how to manufacture this.
When we're reinventing a product, sometimes we have to go through these processes just to prove it out. We had this idea that making an exoskeleton vehicle could work, and so we've been using that time to make sure that that actually is working.
By June of 2022, Elon indicated that design was finally locked.
The design at least finally is locked. We got too carried away.
Nearly a year later, Tesla built its first Cybertruck at its Austin. The new truck represents a major deviation from traditional automotive manufacturing processes.
This is more than 90% different, right? So that means you really have to reinvent the process. Actually, they did a great job putting this together in such a short period of time. The automotive industry, traditionally, all the cars, no fundamental difference except stock. The overall platform is essentially the same because they all borrow or learn from the past. So you don't have to reinvent new tooling and new assembly sequence.
So we actually had to come up with a special, ultra-strong, Tesla-designed steel alloy. This metal did not exist before. We needed something that you could actually manufacture, but have basically no corrosion, didn't need paint, but you can still make it in volume.
Their Vice President of Materials Engineering, Charles Kuhlmann, works for 2 Elon companies in this capacity. He works for SpaceX and Tesla, and they've collaborated on alloys before.
Steel isn't uncommon in automotive. It's frequently used in panels and frames as part of the vehicle's structure. But Tesla's custom ultra-hard stainless steel could have added some unique challenges.
Stainless steel is hard to work with. It's much, much, much harder than all of the grades of conventional steel, which is what the bulk of vehicles today are made out of, including Tesla's high-volume Model 3 and Model Y.
The presses that they needed were very unique presses, massive presses, and that is where a lot of the money would go. And you can't use these presses forever because they start to wear out.
But for automotive, using complete body panel with the stainless steel is the new concept.
Stainless steel in automotive has a brief history. Ford experimented with it in a few of its cars, but never put it into production. The DeLorean, first introduced in the mid-1970s and built from 1981 to 1982, was the first mass-produced vehicle with a stainless steel skin. The company went bankrupt after building fewer than 10,000 cars.
DeLorean used stainless steel. They at least went to the trouble of using brushed metals, but the fit and finish, they had incredible problems with that as well. And so you would think they would either learn from that it's not a good material to use, or they would find a better way to do it.
Tesla's VP of Vehicle Engineering said that Tesla had to invent a manufacturing process called air bending, which shapes the steel with high air pressure without actually touching the surface.
When you bend a piece of metal, you want to maintain certain shape, and the stainless steel tend to be more unpredictable than traditional steel. And if you get into higher strength level, that tend to be amplified.
When they produce the panel, it will actually press it further than where it has to go. The steel will spring back. Sometimes it's this much, sometimes it's that much. So you never know, and that's where you get these quality issues.
And the thickness, which Musk has used to promote the Cybertruck as bulletproof, only further complicates things.
Typically, automotive body panel for passenger cars, you're talking about in the millimeter range. From the limited information I have, we are talking about for the Cybertruck is a 3 millimeter. That's a factor of 9 in terms of stiffness. So definitely you need a lot more force and bigger press to do it.
The flat and angular design is another issue, especially with regard to mass production.
That form introduces tremendous complexity. One of the criteria I teach in my class is stability. A component has to be able to maintain design geometry upon some disturbance. You don't want those disturbances to introduce variability. As you work on it, as you drive the vehicle,
stainless steel is very difficult to work with. When you cut it, all the mistakes basically show up. When you have a flat plane like that, it's really hard to hide the mistakes.
In late August, Elon Musk sent an email to Tesla employees stating, "Due to the nature of Cybertruck, which is made of bright metal with mostly straight edges, any dimensional variation shows up like a sore thumb," and emphasized that all parts for the vehicle need to be designed and built to sub-10 micron accuracy.
Elon has even mentioned that he wants everything to be even better fit and finish than anything else out there on the road. If he achieves the fit and finish level quality of any normal car, hats off to Tesla and hats off to Elon for managing to do it.
Tesla has been using gigacasting, a manufacturing technique that creates large single-piece alloy castings that help simplify the construction of its cars. And the Cybertruck is likely to employ the use of it in its construction.
The primary benefit essentially is a cost and parts complexity benefit, right? You can cast a larger proportion of the vehicle at one time, less complexity, less assembly, less cost.
You can ensure uniformity. For automotive industry, mass-produced products. That's very critical.
The problem is that if anything goes wrong, even in the manufacturing process, now you have to scrap a huge piece.
There was at one point a photo of an entire parking lot full of failed gigacastings. That's part of the development process, but still, can they get all of these new and innovative processes up and running simultaneously in volume?
With the Cybertruck finally here, Tesla must now contend with scaling production.
I think we'll end up with roughly 250,000 Cybertrucks a year, but I don't think we're going to reach that output rate next year. We'll probably reach it sometime in 2025. That's my best guess.
This is scaling a type of vehicle that's never really been done before, and several other technologies that likewise nobody else in the industry has yet tried. But I have every confidence that they'll get it done.
Probably 6 months from now, you'll start to see volumes increase a little bit. And then a year from now, you'll be getting to something at a higher level. It would not surprise me, however, if the Cybertruck ended up being a seller that was more on the par of the Model X volumes.
Besides the difficulty in manufacturing, battery cell production could also be a limiting factor. The Cybertruck is using Tesla's new 4680 cells, and with a 122.4 kilowatt-hour battery pack, it will need a lot of them.
The Cybertruck cell, with 10% higher energy than our Model Y cell, started production on line 2 in Texas. This quarter, we convert to building 100% Cybertruck cells to simplify and focus the factory as we ramp all 4 lines in phase 1 over the next 3 quarters.
I return to a quote from a colleague of many years. This is a man who has built battery factories on 3 different continents. And he said, when you have a new building with a new staff and you're using a new cell chemistry in a new form factor on brand new manufacturing equipment, that's really, 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 really hard.
The decision to rely on that cell form factor, which is still kind of cutting its teeth for this new product, it does pose a risk, but I actually think that it will probably ramp faster than, for example, the Cybertruck might.
With a new vehicle on the road, a lot is yet to be seen how service and repair will work.
Service at Tesla has been a sticking point for a number of years. When you have a new manufacturing process like gigacasting for the Cybertruck, that adds another layer of complexity to the servicing piece.
The moment you scratch a vehicle like this, which you can scratch it and you can dent it, you're going to have a hard time fixing that car, and in that sense it's going to be even more expensive in terms of maintenance.
Tesla has a history of taking on challenging projects despite the risks and delays.
The Model X, when they said, hey, we're going to build this full-size SUV, but we're also going to put Falcon Wing doors on it. The Falcon Wing doors delayed or helped to delay the Model X by 2 years.
I think that what this really shows is that Tesla as a company is still not afraid of taking risks and not afraid of failing on occasion.
But with the first vehicles in the hands of customers and Cybertrucks debuting in Tesla showrooms, the company appears to be making progress.
I kind of wonder if the combination of extreme design and an extreme and new material to make the vehicle out of in a new factory with a new workforce, no less, will prove to be a very long-term drag on the company getting itself up to speed.
Even with all of those things stacked against it, it is going to be a kind of iconic vehicle in the sense that nothing else looks like it, and probably will give Tesla some cachet for sure.
This vehicle has the chance to be something really radical in a pretty normal space, and it's incredibly functional. It's
Limbs Makola, everything you want.
Kedi ko ka kai do America ye bi na me pass bag ni ko unko Ghana di ban ba ye no anyi sardine na de.
Come on, we ehun here say di we me ko bi. Say limbs at aroma. We duru ho a Ghana dwani bia o bi wo ho. Enu so we call limbs Makola. We duru ho a bi bia o ye bia wo ho. Ah what say we ni na ko bi.
Ah say ko e be ka ban ku bia.
Oh, enu so we call limbs Makola. Ghana ye bia o ye bi.
No ne se wo fa. Limbs was the Ghana akwa America.
Aso the Americans so ba Ghana. E se what e bi. We here so be say ma abrochi ho ne ma dia ba enu so be duru na limbs ai ni ready wo hard da.
Very interesting. Any food items no kwa so here car be e de wakoma so e wa America ofre ani a ye beto ni a ship dia ana se wan ka se wato na pese o de bagana ba bia wo bia ye beto akoto car no aba ship dia ba ama any spare parts one okay to Limbs market we are ready to supply Limbs we are too much.